Texan Global School. Radical equations. In this class, different processes are analyzed to solve equations with radicals that can be reduced or simplified to a quadratic or linear equation. Let's look at the first example. Solve the following equation. First, analyze the equation to determine the type of algebraic process to begin its reduction or simplification. A first strategy is to eliminate radicals. However, first, send the linear and independent term to the right side of the equation to simplify like terms. Now square the entire equation to eliminate radicals. Accommodate the equation with properties of equalities and then solve it by any of the methods seen in previous classes. In this case, we can do it by factoring since it is a trinomial of the form x square plus bx plus c. So, calculate the square root of the quadratic term, which is always x in this case. Now, obtain two numbers that, when multiplied, result in -2 and when added, -1. These values are substituted into the factors obtaining x plus 1 times x minus 2. Once factored, set each factor equal to 0 and solve. In this case results two solutions, x1 equals -1 and x2 equals 2. The process yielded two solutions. However, we will verify each result. By independently substituting each value, we can see that the first solution does not satisfy the equality. The process is correct. However, the first one is a false solution. So the solution is x equals 2. In this next example, to solve the equation with radicals, we will directly square both sides of the equation. However, radicals are not eliminated immediately since each radical is a term. So we must use special products since it is a squared binomial, which develops or expands as a perfect square trinomial. We can see that the radicals at the extremes are eliminated, so we can add like terms. Now send the terms without radical to the right member to simplify like terms. Square again, and since the radicals on the side are factors, we can apply laws of exponents and radicals. Hence, radicals are eliminated by squaring each factor. We now perform the product on the right member. We can do it directly, or we can use special products again, like a square of a binomial. Now let us perform the product on the left member. By sending all the terms to the left side and simplifying like terms, results a linear equation, which, upon solving, we obtain that x is equal to -7 over 16. Upon verifying, we can see that the equality is not fulfilled. Although the process is correct, we conclude that it is a false solution since equality is not satisfied. This means that there is no solution in the set of real numbers. Let us remember that all radicals have two signs. So if the second sign is used, the equality will be fulfilled. This is why they sometimes give false positives in equations with radicals. Graphically, it means that there is no intersection with the x-axis, as can be seen in the graph. In conclusion, all possible solutions should be verified. In this last example, solve the equation with radicals. For this type of equations, it is suggested to transform the radicals into fractional exponents using the laws of radicals seen in previous classes. We can see then that the first term is the square of the second, so let us make a change of variable. Let us define w as x to the 1/3. By substituting results, the quadratic equation w squared minus w minus 6 equals 0. Let's solve it by one of the methods seen in previous classes. We can factor directly as w plus 2 times w minus 3. By setting each factor equal to 0 results two solutions, when w is equal to -2 and w is equal to 3. However, this is not the solution. We must return the change of variable since the original equation is in terms of x. We have two equations, x to the 1/3 equals -2 and x to the 1/3 equals 3, or the cubic root of x equals -2. And the cube root of x equals 3. By cubing to cancel the radicals results that x is equal to -8 and x is equal to 27. By verifying, we can see that both solutions satisfy the equality.
Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com.